Problem number five. Problem number five is an interesting question. This little new thing about standard deviation, but it's basically a regular old hypothesis test. We have this machine that's supposed to dispense 12.1 fluid ounces, and it's also supposed to have a standard deviation of 0.05. We don't want the thing being too out of whack, right? So the first thing was just to perform a regular old test to see if the mean is not 12.1. Oh, sorry, I said 12.05 before, but I meant 12.1 is what the machine's supposed to do. So our null hypothesis is the mean is 12.1. Our alternate is the mean is not 12.1. Sample of size 4, run a test. So it's a t-test. They said assume the conditions for inference are met. So when they say that, you don't have to list them. The one condition would be a normal population, which they didn't tell us, but they're just telling us in a roundabout way that it was. So you don't have to list the conditions. You do need to name the test, though, like you normally would. It's a t-test for a mean. These are my data points, mean and standard deviation. Null, alternate, picture, critical values are 3.18. Inverse t, not inverse e, so they're not 1.96, so they're really spread out because of the small sample size. So I did an inverse t of 0.025 with 3 degrees of freedom, one less than the sample size. I got a critical values of 3.18, negative 3.18. Just ran the test, t-test, with this data. I got a test statistic of negative 1.17, a p-value of 32.4%, so really big p-value, small test statistic. It's not in the rejection region. I failed to reject the null hypothesis. So I say there's no evidence of this, right? So there is no evidence that the mean is not 12.1, or in the context of the problem, there's no evidence that the machine is not working. If you're grading, an E, P, and I for all of the null hypothesis and stuff, actually 3 EPIs, yeah, 3 API for this and an EPI for this. And the last one has its own EPI altogether. And this one we're going to test the standard deviation. We don't have the same sort of things that we can do. So what they did is they just ran a simulation to see what was happening. So I didn't draw the whole simulation out, but they had all the pictures. And basically they ran the simulation from a population that they knew the standard deviation was really the 0.05. The null hypothesis is our standard deviation is 0.05. The alternate is that it's not. They ran a simulation from that data. It's just like gathering data, but we can't gather that data, so we run the simulation. And then what I look for here is how many of the data points were 0.085 or greater, as extreme or more extreme. I just counted them. There were 12 of them. 12 of them in there. That was 12 out of the 300 dots, which is 4%. So that's my p-value in essence. What's the probability of getting something as extreme or more extreme than the one I got? So I got a p-value of 4%. Small p-value, less than 5%, so I reject the null, which means there is evidence that the standard deviation is not 0.05. And that's it for that one.